Hello everyone, my name is Nav. Today I'm going to teach you to draw bending moment and shear force diagram in QconBridge. So let's do for a continuous beam that has two spans as shown in the figure previously. So let's use the SI system of units and let's consider the left span with the length of 20 meter and right of 30 meter. So it is a continuous beam, so let's put the left span as pin jointed, the interior support is roller and the right one is roller. And then you can put the section material properties, but to draw the bending moment diagram and shear force diagram we don't need these properties. And you can see that there is live load distribution factor, so I will give you another lecture on calculating the distribution factors and about their importance. Okay, for now we will just draw the shear force and bending moment diagrams. Now what I'm trying to do is to put UDL load on the first span and a point load on the second one. So for the left one, the starting will be 0 of course and the end will be 1. Okay, and let's put a load of 5 Newton per meter and let's put it in a combination like it's a folder under a DC load. Okay, but yeah, here I have done a little bit mistake and we can go back and go to load, and before we have to select the beam and then go to loads and add uniform load, but first of all we have to select the fractional part, so only then it works as 0 to 1. Okay, so put here 5 and click on OK. Yep, now it looks good. And now to add the point load in the second span, go to concentrated load. So we want the load at the mid span, so we'll put 0.5 and we'll vary this value depending upon the position of the load. Okay, and let's put the load of 100 Newton at middle, so we'll put it under the same combination DC, and here we can see that we did it. So when you click on a load and just right click, you can change its properties. For example, look on this load and right click, you can see that you can change these values, you can edit the intensity. Also if you want to edit the spans, you can just right click on it and here you can see that they are like edit spans and several things. It's also in here edit span, edit support and things like that. Again, you can change the length of the span as well and many more. After modeling my beam, now I'm going to analyze these, and to analyze it, go to bridge, analyze, and here I'm putting some numbers of analysis points. These are the points where I'm going to look the values of bending moment and shear force in a particular span. So let's put 5, but you can put as much as you want, like 10, 15 or 20 as per as you demand. So just click on OK, and then the analysis takes place. When it is successful, then you can go in the symbol to look for your bending moment and just right click on this image, and this is our combination or the folder that we kept our load on. So I'll just click on this load combination, so click on OK, and this is the bending moment diagram. Here you can see the bending moment diagram of a continuous beam. So to change the display options, just right click and select the display, and if you want to invert the moment diagram, then you can click on that option, and here you can see that you have inverted it. And you can try different combinations over here and just you can experience it more to be more comfortable with the software. Okay, yeah, so there are other options with the colors as well. So our load is DC, so you can click for this color. Yep, it works and it looks good. Now if you can also check with the shear force, so click on B, then select your loading and click on OK, and there is your shear force diagram. And again, you can change the display options. For this, let's put red one and click on OK. Yep, it works. Now to generate the table, click on view and click on tabular results, select table and select your load combination, and here you can see that there are the values of shear and moment at different points on a span. So there are basically 5 points in each span, so each spans are divided into 2 colors. So if you want to export it to Excel, then you can click on export, and from here you can save it as txt file, as a notepad file. Then from notepad you can copy it to Excel. And there is one other thing that I forgot to mention earlier, and here you can see in the bending moment diagram that there is a horizontal scale and a vertical scale. So here you can see there are certain values on this scale. So like the actual value of this lies between 375 and 500 Newton meter, I guess. Yeah, Newton meter. So but when you enlarge this thing, the scale changes. Here you can see it now. The scale is lower than initially, because right now the paper that the program is using is smaller, so the scale is higher. So it is just a scale. If you print it, you can find it like these values are actually the readings of the current scale that the bending moment is shown on, and there is nothing more to confuse on. Okay guys, thank you for watching my video. If you really liked it, please hit the subscribe button, and thank you very much.